So this is a mod 10 counter. We have a 4-bit binary up counter which counts from 0000 to 1001. Once it reaches 1001, it will roll back to 0000. So what is this, students? This is a 4-bit binary up counter. Okay. So here,
Excuse me, ma'am.
yes. So this is a mod 10 counter which counts the counting sequence from 0000 up till 1001. Once it reaches 1001, it will roll back to 0000, right? So here this is a 4-bit binary up counter actually. Okay, actually it counts from 0000 up till 1111, but we have to make the that it counts from 0 to 9 counter which counts from 0 to 9. 9 in binary is 1001. Once it reaches 1001, it will roll back to 0000 and then again start counting sequence 0001, 0010 up till 1001. So totally how many states are there? Totally 10 states are there. Hence it is known as mod 10 counter. So what are the modifications to be done to this 4-bit binary counter in order to act as a mod 10 counter? We need to use a AND gate. Okay, see, for 1001, which states are 1? Q3 and Q0. So take the Q3, this connection pertains to Q3 and this connection pertains to Q0. They take these two connections with the help of a wire and give as an input to the AND gate. Once the Q3 and Q0 becomes 1, Q0, Q3 and Q0, if both are 1, then the output of the AND gate will be 1. If the output of the AND gate is 1, it is given as an input to the load. Load becomes 1. Okay, so load has a higher precedence than the count. Okay, so load has a higher precedence than count. Once load becomes 1, it will load back in the D0, D1, D2, D3, it will load 0. You can see here these D0, D1, D2, D3 are connected to 0. Okay, so once it reaches 1001 state, that means Q3 and Q0 becomes 1, the output of the AND gate becomes 1. It is given as an input to the load. Load becomes 1 means the D0, D1, D2, D3 inputs are loaded with 0. On the positive occurrence of the clock, on the positive edge occurrence of the clock, the D0, D1, D2, D3 will be loaded with 0. Again for the next occurrence of the clock, it will be loaded with 0001. Again with the next occurrence of the clock, positive edge occurrence 0010. Similarly, it will come up till 1001. Once the Q3 and Q0 again becomes 1, the output of the AND gate becomes 1. This is given as an input to the load. Load becomes 1. Once the load becomes 1, the D0, D1, D2, D3 will be loaded with 0 input. When it will be loaded? On the positive edge occurrence of the clock. These count pulses on the positive edge, the D0 to D3 inputs will be loaded with 0. Upon the occurrence of the positive edge of the clock, it will go to the next state. So totally how many states are there? 10 states are there. State 0, state 1, state 2, state 3 up till state 9. State 0 to state 9, totally they are 10 states. So the counter is having different distinct 10 states. Hence it is known as mod 10 counter. Okay, here you should remember that there is a load signal, there is a count signal. Count is 1 for counting sequence. Count will be 1 for counting the sequence 0, 1, 2, 3 like that. Load will be 1 to load the inputs for 0. Okay, so load is having, even though count is 1, load will be given a higher priority than the count enable signal. Okay, count enable signal is for counting, okay, for counting the states 1 0 1 2 3 for the counting sequence. Load enable signal is 1 means to load the inputs with 0. Okay, so what you have to understand this is actually this box significance 4-bit binary up counter. Actually it counts from 0 to 15. Total 16 states are there because it is a 4-bit up counter. But we have to do the modifications in such a way that it should count only different 10 states. How to count 10 states? Just take a AND gate. 10th state is 1001, Q3 Q0 or 1, take Q0, take Q3, give as an input to the AND gate. It will detect once Q3 Q0 are 1 and it will load this load signal to 1. Load signal is having higher priority than the count. So once the load is 1, the D0, D1, D2, D3 will be loaded with 0. Upon the occurrence of the positive edge of the clock, it will be loaded with 0. Upon the next occurrence of the positive edge of the clock, it will be loaded with state 1. That is 0, 0, 0, 1. Okay, so it will count up till 1, 0, 0, 1. So totally 10 states. So this 4-bit binary up counter is modified with the help of the AND gate, okay, to count only 10 states, 10 different states. So it is known as mod 10 counter. This is a synchronous mod 10 counter and we have shown the connections here. Count pulses are there, count enable signal is there, load signal is there, D0, D0, D1, D2, D3 are the inputs, Q0, Q1, Q2, Q3 are the outputs. Okay, see you can see here Q0, Q1, Q2, Q3. C0 is carry out. It becomes 1 when the count reaches 1, 1, 1, 1 for the normal binary up counter. This carry out signal is used for the cascade connections. Okay, for the cascade connections means for the higher number of bits. Now it is 4-bit counter. No, I want to increase it to 8-bit counter. So in order to have 8-bit counter, how many 4-bit counters are required? Are required 2 4-bit counters. So in order to construct a higher bits binary counter, we need to have cascade connections. So at that time this Cout is used. Okay, so these are the connections. These are the connections modified, okay, for to count this counter up till mod 10 counter, that is it counts from 0000 to 1001. So these the first one is the connections, second one is the counting sequence. Counting sequence is 0000001 up till 1001. Once it reaches 1001, it will roll back to 000. How it will roll back? With the help of the AND gate. Okay, Q3, Q0 is connected. If both are 1, output of the AND gate is 1, it is given to load signal. Load signal is having higher priority than the count signal. So load signal becomes 1, then on the positive occurrence of the clock, it will be loaded with 0. Again on the next positive occurrence of the clock, it will be loaded with the state 1, state 2, like that state 9. Up till it will count up till state 9. So this is about the mod 10 counter. Any doubts? Any doubts?
Excuse me, ma'am.
Yes.
Ma'am, is there a case that
Hmm.
0 other than 1?